Dear students, in this session we will consider what happens to equilibrium level of income and output when there is a shift in the aggregate spending function. From one time period to another time period, aggregate spending function shifts upward or downward depending on what happens to the components of aggregate demand. And in a two-sector model, aggregate spending function consists of consumption function and investment function, and Keynes believed that consumption function is relatively stable and investment function is relatively unstable. Stability of consumption function does not mean that actual amount of consumption is stable. Actual amount of consumption will change with every change in income from the consumption function, as we have studied. So, stability of consumption function simply means that the amount of consumption expenditure at any level of income is stable. That initial change in the level of income is the result of shift in investment function. So, stability of consumption function simply means that consumption will not fluctuate considerably from one time period to another time period unless there is a change in income. And income changes if and only if there is a shift in investment function. Consumption cannot fluctuate independently. It fluctuates only when income changes. So, in the Keynesian theory of income determination, aggregate demand curve fluctuates over time mainly due to instability of investment component or instability of the investment spending rather than the consumption component. And as we have seen, in the simple Keynesian model of income determination, equilibrium level of income and output is determined by aggregate demand. And if there is a change in aggregate demand, equilibrium level of income and output will also change. If there is a change in aggregate demand, equilibrium level of income and output also changes. Now, as consumption is a stable function of income, we consider change in the equilibrium level of income and output resulting from a shift in investment function. And what we do here is, we compare two equilibrium positions corresponding to two different levels of desired investment. We consider two equilibrium positions corresponding to two different levels of desired investment. That is, an initial level of investment I and a new level of investment I plus delta I. Maybe because entrepreneurs become optimistic over time so that they plan to spend more on investment. We assume that this decision of the entrepreneurs to spend more on investment is independent of the underlying economic conditions. So again, I is assumed to be exogenous. So the resulting impact on income and output can be depicted both graphically and also mathematically. Let us first consider how to depict it graphically. Now, The initial equilibrium is given as y, E, the 45-degree line, C, and C plus I. Equilibrium level of income is y1. Equilibrium level of income is y1, given by equality between I and S. In terms of saving in investment equality between I and S. In terms of aggregate demand and aggregate supply, it is given by C plus I intersecting the 45-degree line, the aggregate supply line. Now, investment increases from I to I plus delta I and aggregate demand schedule shift up to C plus I plus delta I. C plus I plus delta I. As a result of this increase in aggregate spending, equilibrium level of income increases from y1 to y2. And in terms of saving in investment equality, I plus delta I is equal to S, the new equilibrium y1, y2, y1, y2. So initially equilibrium is at point E1, now the equilibrium is at point E2. Equilibrium is E2. Now as you can see, when there is an increase in investment expenditure, equilibrium level of income increases from y1 to y2. This increase is possible if and only if initially the economy is at less than full employment equilibrium. In the Keynesian model, remember the specific type of aggregate supply function we have considered. If there is an increase in aggregate demand, only output will increase. Prices are not affected. But in the classical model, as you know, if there is an increase in demand, as economy is at a full employment level of income, output will not increase, only prices will increase. So remember this increase in income is possible in the Keynesian model only because economy was working at less than full employment. Now you can also see that in this case delta y, this is delta y, is greater than delta I. Delta I is this. Or we will say that increase in income is a multiple of the increase in investment, and this multiple is obtained as M is equal to delta y by delta I, and this multiple is known as the investment multiplier. Is known as the investment multiplier. So M is the investment multiplier. It can be defined as the investment multiplier. M is defined as the ratio of the final change in income to the ratio of final change in income to initial change in investments that stimulated it. The ratio of final change in national income to initial change in investment that stimulated it. That is one definition. It can also be defined as the multiplier is the amount by which equilibrium output change when autonomous aggregate demand increases by 1 unit. The multiplier is the amount by which equilibrium output changes when autonomous aggregate demand changes by 1 unit, or it is simply the ratio of change in income to change in investment, the final change in income to initial change in investment. Now, let us see how this equilibrium, the value of this multiplier is calculated mathematically. We know that y is equal to c plus I. In equilibrium, y is equal to c plus I. And if we retain the same consumption function and assuming an upward shift in the investment function, equilibrium level of income and output changes. This can be written as y plus delta y is equal to c plus delta c plus I plus delta I. C plus delta c plus I plus delta I. And from which, subtracting second from the first, delta y is equal to delta c plus delta I. We can write delta y as equal to delta c plus delta I. And given that c is equal to a plus by, the linear consumption function, we can write delta c as equal to, we can write delta c as equal to b into delta y. We can write delta c as equal to b into delta y. So, delta y is equal to b into delta y plus delta I. Delta y is equal to b into delta y plus delta I, and delta y into 1 minus b is equal to delta I, or we can write delta y by delta I as equal to 1 by 1 minus b. 1 by 1 minus b, which is nothing but m. So, multiplier is 1 by 1 minus b, and b is the marginal propensity to consume, as we have defined earlier. So, value of the multiplier depends on MBC, or we will say that multiplier is the reciprocal of MBC. That is, larger the value of MBC, larger will be the value of multiplier. For example, if MAC is 0.5, the value of multiplier is 2. If MBC is 0.8, value of the multiplier is 5, etc. So, as the value of the MBC increases, value of the multiplier also increases. So, the point is delta y by delta y is m. M is equal to 1 by 1 minus b, and this quantity is known as investment multiplier, and investment multiplier is defined as the final change in income to the initial change in investment which has caused it. And as long as MBC is between 0 and 1, value of the multiplier is greater than 1. Since 1 minus 1 by b is MBS, we can also write it as 1 by MPS. We can write multiplier also as 1 by MBS. Delta y by delta y is equal to 1 by 1 minus b, also equal to 1 by MBS. So, if MBC is 0.8, MBS is 0.2, so 1 by 0.2 is 5. Now, in the form of a definition, in the figure and also in terms of the equation, a shift in aggregate spending function results in a movement of income and output to a new equilibrium level by some multiple of the shift in aggregate spending function. A shift in aggregate spending function causes income and output to a new level which is a multiple of the initial increase in aggregate spending function. The value of this multiple is known as multiplier, and represents the number by which shift in aggregate spending function must be multiplied to determine the change in level of income and output required to establish new equilibrium. So, the value of this multiple is known as multiplier, and it represents the number by which aggregate spending function must be multiplied to determine the change in the level of income and output required to establish new equilibrium. Now, the crucial question is, why does income changes by a multiple of the initial change in investment, or why does income changes by 1 by 1 minus b or 1 by MBS for each change in income? Now, as you can see, delta y is equal to 1 by 1 minus b into delta I. If this value is 5 and this is 100, change in income is 500 like this. Now, the question is why income changes by a multiple of initial change in investment. The process behind the multiplier is like the ripple effect of throwing a stone in a pot. The initial effect is the stone disturbs the water. Added to this is the effect on the rest of water surface as disturbances by water displaced by the stone is spread to adjoining water with the intensity diminishes from the initial point of impact. If a stone is thrown into water, it creates one ripple followed by another until the entire water surface is disturbed. Now, the initial change is delta I. Initial change is an increase in investment equal to delta I, the initial disturbance. So, investment change is the initial disturbance. Let this initial disturbance I is equal to 100. I is equal to 100. Now, some firms experience increased demand for investment goods as a result of increase in investment. So, their output increases. That is, those industries producing investment goods experiences an increase in demand, so their output will increase. As a result, payment to factors will also increase. So, households will get an increase in income equal to 100. Now, with the delta C less than delta Y, delta C less than delta Y. And this is the beginning of the indirect effect of the shock. This is the beginning of the indirect effect of the shock. And suppose that delta I is 100 and also that MBC is 0.8, MBC is 0.8, there is an additional increase in consumer demand equal to 80. This generates a second round of increase in production. Again, income increases. Then consumption increases by 64 like that. And this process will go on until the impact of an initial increase in investment will be spread all over the economy. That is, this can be written as delta y is equal to delta I plus, that is 100 plus b into delta I 80 plus b square into delta I 64 plus etc. Delta y can be written like this, and this can be written as delta I into 1 plus b square plus etc. Delta y is equal to delta I into 1 plus b square etc. and delta y by delta I is equal to 1 by 1 minus b. Delta y by delta I is equal to 1 by 1 minus b. And this is how the multiplier works out throughout the economy. Multiplier works throughout the economy. Delta y is equal to, this is because the terms inside the bracket is an infinite geometric series, and this sums to 1 by 1 minus b. 1 by 1 minus b, and the exact derivation of the formula will be considered in a later class. So the ultimate increase in income is a multiple of the initial increase in investment, and the value of this multiple is known as the investment multiplier. The value of this multiple is known as investment multiplier. Now, consider this. In the previous class, we have introduced C as equal to 100 plus 0.8y, and the equilibrium condition is y is equal to c plus I. Let I is equal to I bar is equal to 20. Now, what is the equilibrium level of income? This is equal to 1 by 1 minus 0.8 into 100 plus 20, that is 5 into 120 is equal to 600. What is the corresponding consumption? C is equal to 100 plus 0.8 of 600 summum 580. So consumption is 580, and what is savings? Savings is minus 100 plus 0.2 into 100 is equal to 20, which ensures equality between saving and investment. So given an initial level of income etc., we have equilibrium level of income, equilibrium level of consumption. Saving is equal to investment. Mathematically, this is how we derive equilibrium in the simple Keynesian model of income determination, where there are only two sectors, households and business firms. You can practice with the examples.